Biometrics and participatory art. And the first question maybe that comes to mind is, like, why bother? Why bother with that? And so here's just a real quick sort of visual, like sort of pictorial representation of maybe why bother. And so there's 4 images here. The first one is somebody's just talking to you. And the second one is there's you with, that's a top view of your brain. And then there's your body. And then over here on the lower right-hand corner is a kind of coming to judgment. And so what happens actually is that when the data comes, like as I'm speaking to you, moving my hands, and you're hearing my voice, is that the data takes about, once it arrives to you, it takes about 50 to 100 milliseconds to arrive at your brain. And it bounces around in there for about a half a second after it arrives. And then after about 600 milliseconds, after the data comes in through your eyes or ears, in this case, through your ears, about 600 milliseconds after that, you come to judgment, which is that lower right-hand corner. And in the meantime, in that time period, that 100 or 50 millisecond to 600 millisecond period, what happens is your body mobilizes. And what I mean by that is that many years of evolution, thousands of years of evolution, has resulted in this phenomena by which when data comes in, we mobilize to it. So meaning that we have maybe a change in our heart rate, we have a peristaltic contraction in our stomach, we have a blink of an eyelid. These things all happen before we come to judgment. And you can think about this process as, so there's like a kind of a physiological expression in the body. And that creates, William James talked about this idea about like, what is an emotion? And an emotion, he thought, was this idea, or it's you receive the data, there's an expression in the body, there's a feeling, and the emotion is our label of that feeling. And so you can think about, we're sort of moving around this world, and we receive this data, and there's physiological responses that happen. We generate these feelings, and that creates a kind of emotional, motivational state, like a substrate. And our higher level thought processes, our coming to judgment processes, sit on top of that emotional, motivational state substrate, which is in part characterized by this physiologic expression. And so all these projects that I'm going to point at explore this domain of this 100 to 600 millisecond domain of what it's like for us before we come to judgment. So this is just touching briefly on what I talked about, this idea of an emotional, motivational state substrate for people. And often that's thought of in psychophysiological thought as this axis is valence, pleasure to displeasure. This axis is arousal. And then there's a third axis called motivational state that has to do with challenge and threat. And then there's physiological markers that, over here to the right, this is called Russell's circumplex model of affect. And then there's physiologic markers which indicate these states in people. So one of my first exposures to this idea for collective physiologic expression was this project done by the AT Lab. And so this was back in 2011, and this had the characteristic, I had just a very small part of this project, and there was a physiologic system. I brought a kind of heartbeat amplifier that resulted when the individual put their hands inside these mufflers, and there were conductive plates in there, and so their heartbeat filled the chamber, the warming hut, and with a sonic component and also auditory component. So it was an individual physiologic expression to those sitting inside of the warming hut. That led to this project here called the Reincarnation Lounge Chairs, and this was a little bit different, built on that, this idea of a dyadic peripheral nervous system exchange. So one individual, their heartbeat is transmitted to the other chair, so one person feels the other person's heartbeat, and vice versa. And what it shared in common with the AtLab project is that all this is occurring in full real time. These are full analog systems, so they're highly responsive and very nuanced. There was a mention to tokens earlier, which I totally related to. And so this is a system that has no tokens. It simply is the data. So that led to further work where it kind of expanded into this idea. I didn't coin this term. It's called group flow. This is coined by this fellow named Mikey Siegel, and he's the founder of the consciousness hacking movement started in Santa Cruz and then evolved into now worldwide there's chapters. But so this is a group physiological monitoring session where there's kind of a shared experience. And that became increasingly sophisticated. And what separated this from previous experiences is that these, as they began to be more complicated, you can think of the physiological data as a kind of language, so that's an expression. And so when you had this number of people involved, it needed to be mediated and facilitated. And so it required a lot of hardware. And so here's one of the facilitators. He's kind of, in a way, sort of orchestrating the experience through the use of MaxMSP. This is a fellow named East Forrest, and he's composing in conjunction with the collected physiology from the group. Kind of a physiologically mediated artistic experience that's fused with a musical presentation. Oh, and here's a final example. This is 24 people, and so that was a group physiological experience. There's 24 people, and the light and the sound, that was actually more of a tokenized experience, where the sound was, the heartbeat triggered a sound which was correlated to that individual. So moving on to the biometric campfire, this is kind of reducing the problem again, not to so many people, but to fewer. And there's a little schematic representation. And it's a center pillar here, which has group data about the nature of the electrocardiogram signal that's being recorded from everyone. And then there's also a soundtrack that's created that's a function of the timing and the magnitude of everybody's heartbeat. And there's an evening picture, a project called Hand to Heart. Try one more. So in this project here, it's back to the dyadic communication. And this lady here, she has electrodes attached to her body, and so it's collecting her electrocardiogram data, and then it's transmitting it to a heart that has haptics transducers in it. So and that's full analog system. And you can sort of see how the heart's changing depending on how she's breathing. And so it's as if this fellow's holding her heart in his hand. And it's a recent project in San Francisco called Enchanted Glade. You sit in these chairs and they reflect in the environment visually. And new work, a heart space. This is a project that's going into Las Vegas, and it involves individuals that are in front of large mirrors, and they hold these spheres, and the spheres collect their electrocardiogram, and there's a holographic display that presents the electromagnetic field from their heart in a fashion that can be reflected to all the other people inside of that space, so that you have a chance to sort of experience what that would be like for you personally, the electromagnetic field from your heart, but also everyone else's at the same time. And I'll stop there. Right, thank you.
Alan, the first diagram that you demonstrated was one which spoke of an extraordinarily nuanced period of time, which was before we are thinking consciously or coming to judgment. That is perhaps half a second.
Yes.
Could you give us more technical information about what is happening during that period?
Sure, yeah, absolutely. So one of so I work in this area of psychophysiology, and in particular, there's an aspect of that called evoked responses, which is where there might be a sound or a flashing light, and that the first experiments involved just those simple things. And so there, what would happen is researchers could put electrodes on the scalp, and they could see that the data, once it was presented, they could measure that when it was presented, and then they could see precisely when the signal in the brain occurred. And for a visual evoked response, that's about 100 milliseconds, so a flashing light, and for an auditory evoked response, it's about 50 milliseconds. And then there's subsequent waves as well. And so there began to be this very, very clear picture of the brain, of the senses and the brain acting together in a kind of concert that would process data, and there would be very deterministic relationships between like the origin of the data, or the timing of the input data, and sort of the reflection of that in the brain. Super repeatable, to the point of being able to put them on an infant even before the infant could talk, way early, just after the child was born, to determine if the child could hear or not. Because you could put electrodes on the child's head, you could present this acoustical test, and you know right away if the child has a functional auditory system. That degree of precision. And then on the flip side, this kind of idea of coming to judgment, it's a little bit slippery, that part, because there's this question about like, well, what's a reaction and what's a coming to judgment? But an example would be like the N600, which is a very complex stimulus and response test. And the stimulus is very detailed there. It's, imagine reading a book and you see a grammatical error in the book. And that activity evokes an N600, which is a negative going wave, 600 milliseconds after you perceive the grammatical error. And so that's a kind of marker by which they figure, okay, it's a pretty high level cognitive process, and but it's fairly repeatable. And they don't know of anything that's sort of that complicated that occurs before 600 milliseconds. So that's kind of the earliest point someone could come to judgment. And then when I've had the opportunity of speaking to a movie director not so long ago, and they said, when we cut a movie, we don't know about the 600 millisecond thing, but we totally know about the 3-second rule, which is that if you want the audience to understand what happened, you never cut a scene shorter than 3 seconds. And so from that data, one maybe could perhaps conclude that you come to judgment somewhere between 600 milliseconds and 3 seconds after the data comes in, for the most part. Any other questions? Yes.
I'm fascinated by the externalizing internal sensory data, which are usually, at least in my perception, suppressed. So I can't watch the heart examples. I basically cannot. It just makes me instantly revolt. It's like not revolt in a sense, but it becomes too internal. I find that fascinating, and I know that for a long time. I wonder, and it's not about the heart, so it's just about paying attention to something that I'm sensing all the time, right? But it's basically not the dominant sensation, because it would basically overrule everything else, right? Which I find fascinating from the sort of internalized, externalized sensory bias that we have as beings basically in the world. So I'm wondering if you have looked at other internal sensory data that you can measure, but that we kind of are not consciously aware of, and basically externalizing them into an architectural context, like, let's say, like you're doing it with a heartbeat.
Other physiological signals other than the heart.
I mean, the brain waves is another one, right?
Yes.
You basically talk about it, but you don't show examples of actually externalizing it, but it's more like an underlying.
Well, there's many. One really interesting one right now, it's very hot in psychophysiology, is this idea of, I remember presented that third axis, the motivational state. You had valence, arousal, and then along the z-axis, it was this other state, and it's defined as challenge and threat. And so that's indexed actually by the relationship between the electrical signal in the heart and the mechanical contraction of the heart. And so it's called, and there's a term for that called pre-ejection period. And so by looking at that, you can get a super clear idea of just are you a little challenged by the activities? Are you a lot challenged? Are you, a little bit threatened? Are you a lot threatened? It's a very nuanced timing variable that looks at those things that occurs much quicker than the time that it takes for you to come to an opinion about something. So that would be another example. Another one is the eccrine response, skin sweating that you have on your fingertips, a change in respiratory depth, the relationship between the volume at the thorax versus the abdomen, facial muscles, like the facial electromyogram, microfacial expressions like corrugator or zygomaticus. These ones.